As educators in architecture, building design, and construction engineering, we are constantly asking a critical question. How do we best prepare students for the realities of professional practice while still nurturing design thinking and critical inquiry? Revit is one of the tools that helps us answer that question. It is not just a software application. It is a platform for teaching how buildings are conceived, developed, and constructed in the real world. Revit is a building information modeling, or BIM platform, used across the architecture, engineering, and construction industries. Unlike traditional drafting or isolated 3D models, Revit allows students to work within a single, data-rich digital building model. In Revit, every element, walls, floors, structural systems, and building components is intelligent, connected, and responsive to change. When students modify one part of design, those changes are reflected throughout the entire model. This makes Revit a powerful teaching tool for understanding buildings as integrated systems rather than disconnected drawings. In the classroom, Revit supports a wide range of pedagogical goals across disciplines. In the architectural design studios, students can move fluidly from conceptual massing to detailed building systems, exploring spatial relationships while maintaining technical accuracy. Plans, sections, elevations, and three-dimensional views all come from the same model, which reinforces the connection between design intent and representation. In building design and technology courses, Revit helps students visualize assemblies, materials, and construction details. It allows abstract concepts like building envelopes or structural logic to become tangible and testable. In construction engineering and construction management programs, Revit introduces students to coordination, quantities, and data-driven workflows that mirror professional practice. Students begin to understand how design decisions impact cost, sequencing, and constructability. From a faculty perspective, Revit is most valuable when it is positioned as a learning medium. Rather than teaching software commands in isolation, educators can use Revit to support project-based learning, interdisciplinary collaboration, and critical problem solving. You can encourage your students to think systematically, to understand how architectural, structural, MEP, and construction decisions influence one another. Revit also makes students think visibly. Educators can assess not just the final drawings, but the logic, consistency, and decision-making behind the model itself. BIM is now a standard across the AECO industry, and familiarity with Revit gives students a strong foundation for entering the industry. Through Revit, students develop essential skills: three-dimensional and spatial reasoning, interdisciplinary coordination, and data-informed decision-making. They gain confidence working in environments that reflect how buildings are designed and delivered today. More importantly, they learn a new way of thinking, one that values collaboration, precision, and the relationship between design and construction. When we integrate Revit thoughtfully into our curriculum, we are not just teaching software. We are equipping students with the tools and mindset needed to design, analyze, and build the future. Revit empowers educators to bridge theory and practice, and empowers students to see their ideas take shape as real, buildable systems.